This is a very standard trig problem where you're asked to compare, you're given a right triangle and you're asked to compare the trig ratio, sine A, cosine C, etc. So what's the most important thing? You want to number this triangle. Then it's going to be so easy to solve. So let's number it, and the easiest number is 3, 4, and 5. So this is the Pythagorean theorem. So you get 3, 4, and the hypotenuse is 5. Now let's remember this idea, SOHCAHTOA here, right? So what is sine? Sine is opposite over hypotenuse. So opposite over hypotenuse. What does it mean? Opposite means if you have a side, it's kind of like if you have sine of A, then the opposite is going to be 3 because it never touches these sides. So that's the main idea. Cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. Now let's look at the sine of A. So what is sine of A? Let's look at sine of A. This is the A angle and you're given opposite. So opposite means the side that never touches A. These two are touching A, right? The opposite never touches it, so this is going to be equal to 3. So therefore you write sine of A is equal to 3 over the hypotenuse. What's the hypotenuse? No matter what, the hypotenuse is always the longest side, this 5. So that's your first answer. And then what is cosine of C? Let's try to write it down. Cosine of C is adjacent. So, but you're looking at C now. This is C. The adjacent is going to be 3. It's the one that touches C. This is the opposite. This is the adjacent for C. So therefore you write down 3, and then over hypotenuse is 5. So you just write down 5. So you got 3 over 5, 3 over 5. Therefore sine of A is actually equal to cosine of C, and this is the correct answer. Automatically these are out. Remember, the most important thing here is to number these sides. That's the easy shortcut. Once you have it, everything is easy. All right, now it's your turn. Cosine of A this time is equal to sine of which angle? So that's the first question. See if you can answer this. Cosine of A is sine of which angle? You again want to take the ratios and find it out. And then the second challenge is tan of the angle C is equal to what trig ratio of the angle A? Is it sine, cosine, cotangent, secant? Which one is it? Tan of C is equal to what ratio of angle A? So comment your answers below. I'll be waiting, and let's move on. This is an easy trig problem again. You've got a right triangle. So remember, right triangle means it's 90 degrees. And if you have 90 degrees, you just want to use the Pythagorean theorem. Remember, these values here are 12 and 16. So the way you solve this is you're going to write down C squared is equal to 12 squared plus 16 squared, which is equal to 144 plus 256, and this is equal to 400. You can use a calculator for this. So C is equal to the square root of 400, which is equal to 20. So that's the first thing. This value over here is actually 20 now. So now that you got this value 20, you just want to find out the ratio, right? So remember the cos ratio, you want to write down SOHCAHTOA. So SOHCAHTOA is sine, cosine, and tangent. Here, you're only thinking about cosine, which is equal to adjacent over hypotenuse. So what is cosine of n? Let's write this down here. Cosine of n is equal to, here's n, and then cosine of it is equal to adjacent. The n values here, adjacent is the smaller side. This is the larger one, is the smaller side that touches n. So this, not this one, but is this one. So you can just write down 12, and then you write down the hypotenuse, which is the longest side ever in this triangle. Okay, so that's going to be equal to 20. So therefore you write down 12 over 20, and boom, that's your answer. So it's 12 over 20 right over here. Now it's your turn to find out what is the sine of the angle L. Sine of L is how much? And remember, this is L, and then you want to use sine is equal to opposite over hypotenuse. So opposite and hypotenuse. What is the opposite of this guy? The side that never touches L, which is this one, and so on and so forth. So post your answers in the comments. Let's see if you can solve this in less than 10 seconds. All right. This is an easy trig problem, and they're asking the degree here. So the first thing, I've just redrawn this over here just so that it's clear for us to read. But then you're asked what is the measure of angle A. So let's remember this idea. You've got SOHCAHTOA, right? And then let's try to identify, they're asking angle A. So in this angle A over here, you've given 13. So remember, this 13 never touches A, and so therefore the side that never touches A is the opposite, and the longest side is always going to be the hypotenuse. So you've got O and H here. So the only ratio which has O and H is the sine. So let's write it down over here. Sine of A is equal to O over H. We want to find A, but before that we want to find out what is this ratio. This ratio is 13 over 16. That's the important idea. Now if you're ever asked to find the degree, you want to use your calculator, and then you want to, instead of doing sine, you hit the shift button here, the shift, and then you hit the sine, and then you put in this number. and then press enter. So shift, then sine, and then put 13/16. Sometimes instead of shift, you might have the second. So either of these buttons on the top left you want to hit, and then the sign, and then you're gonna put in the number, and then you get your answer. So I get the answer directly of 39 degrees. So therefore, this is my answer. Now you try to solve this problem instead, but now you want to find out what is the measure of angle B. So one more time, you go to B, and then you do the same thing. You want to use SOHCAHTOA, but this side is what now? This side is the one that touches B, and so therefore it's the adjacent. This is the longer side, and so is the hypotenuse. Now which of these ratios has adjacent over hypotenuse? Find that ratio, then do shift of cosine of that ratio, and that's going to give you your answer. So post your answers and let's move on. Now you're given in these two triangles. These two triangles are first, they're similar, and then also one of them is 90 degrees, and you see these trig ratios. So obviously this is a trig problem. So the first thing is you want to draw it out. So you want to draw x, y, z, and remember x is 90. So I've already drawn these. So you've got x, and then you've got y and z here. Now how do you always draw a similar triangle? So the best triangle to draw is the 3, 4, 5, and it's similar. So what I'm going to do is I'm just going to double it, because similar triangles, I just doubled it. The scale factor is 2, and remember xyz is similar to qrs, so I'm going to write down qr and s over here. Now I just double every single number. You got 6. It's easier to calculate things this way, and you've got 10. So 3, 4, 5 becomes 6, 8, and 10. All right. So now the first thing you want to remember is sine of y is equal to sine of s. Of course, before this, you want to write down what is the SOHCAHTOA thing, right? The trig thing, SOHCAHTOA. Okay, and then you want to think about what is the sine. So what is the sine of y? So sine of y is equal to opposite over hypotenuse. So therefore you write down 4. This is the opposite. So remember, this is the opposite side. So you want to write down 4, and then the hypotenuse is 5. Okay, now here's an important thing. Sine of y is 4/5. Now you want to remember what is sine of r. So sine of r is also opposite over hypotenuse. You can see is the same thing. It's this over this. So you want to write down 6 over, my bad, you want to write down 8/10, but you'll see you'll reduce this 8/10, and then you get this exact same number. You get 4/5. So that's the big learning here. Sine of y is exactly equal to sine of r. In other words, if it's the corresponding angle, then the actual values are the same. So rewriting this, sine of y is equal to sine of r, right? But sine of y is given to be sine of s, which is not the corresponding side. It's some other angle. So therefore you can cross this off. Let's look at this one as well. Cosine of r is cosine of z. So cosine of r should be equal to cosine of which angle? Cosine of r over here should be equal to cosine of z, but it's given, my bad, cosine of r should be equal to cosine of y, but it's given to be cosine of z here. So therefore you can cross this out as well. Now let's look at this next one. Now you actually want to solve this. So cosine of y is equal to this ratio, which is adjacent over hypotenuse. So let's see, adjacent means 3 and hypotenuse is 5. So you write this as 3/5, and then you write down sine of q. So let's see, sine of q. So what is sine of q over here? This q is 90 degrees, so it's clearly not one of these angles. So therefore this is not the answer over here. So let's move on to sine of r. So let's write down sine of r. Let's do the same value here. Sine of r is equal to, this is the r value, so sine of r is equal to 8/10. And this you can reduce as 4/5. And then let's try to find out cosine of z. Cosine of z is equal to, over here you've got z. Cosine of z is equal to adjacent over hypotenuse, so you write down 4/5, and there you go. You've got these two values as the same. So therefore this is your answer. This is out. So let's summarize real quick what we did. You've got sine of y. The sine of y should be exactly equal to this corresponding side. So sine of y should actually be sine of r, right? Then what is cosine of r? The cosine of r should be equal to cosine of y. Very simple. That's all you need. And then the last one is cosine of y is equal to sine of q. But sine of q is like this weird right triangle, so therefore you can eliminate all of these three immediately. You don't even need to solve anything. And then of course we actually try to evaluate this. Remember, this is the cofunction property. Sine of this angle should be the cosine of this angle and the cosine of this angle. So those are the important things. Now you try to find this answer. Sine of y is equal to cosine of which angle? Sine of y is equal to cosine of which angle? over here? Is it cosine of S or cosine of R or cosine of Q? Simple. You just find the ratio of sine, which is going to be 4 over 5, and then which of these has the same 4 over 5 ratio. So comment your answers. I think you'll be able to solve this in less than 15 seconds. Let's see. This is such a wordy looking, complicated looking problem, but actually it's super easy. Remember, they're giving you this three-dimensional right triangle over here. I'll just redraw this again over here. So let's redraw this triangle in a better way. And then what they've given is this length. This length is 5, and this, my bad, this length is 5 and this length is 1.2. So if this is 5 and this is 1.2, then what is this length over here? This length is 5 minus 1.2. So what is 5 minus 1.2? It's 3.8. So in this other triangle, I'm just going to write this as 3.8 over here. Now what they've also given is this angle over here is 14. So I'm just going to write this as 14 degrees here. So this length is 3.8 and then this angle is 14, and they're asking you what is this length here. So let's call it X, right? And now simple, you just want to find out this length. So with respect to this 14 degrees, this value is your hypotenuse and this value over here is your adjacent. So you just want to write down the SOHCAHTOA formula. So you've got SOHCAHTOA here, and so therefore the only part which has the adjacent and hypotenuse is over here. So you can write down cosine of this angle 14 degrees is equal to adjacent, which is 3.8, right? 3.8 over X. And so you just simply want to solve it. You cross multiply, you get X times cos 14 is equal to 3.8, and then you can move this cos 14 below cos 14 over here, and then you just punch in your calculator and you'll get your answer as 3.92. Remember, you want to round it to the second decimal. So try this problem again by yourself. Now this problem is very important, so try the same problem here, but I'm going to change this 14 degrees and I'm going to make it 30 degrees, and now try to find this length again. So remember, you want to use the same idea. You use the cosine and you write down cosine of 30 degrees is equal to blah 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 over blah blah blah, and then this value is something that you want to find out. So comment your answers. Let's see how quickly you can solve it. This is a solid trig problem, so you can retool this problem if you'd like, but the most important things are this length, this height is 50 meters, then this angle over here, this larger angle is 22.2 degrees, and then this smaller angle is 13.3, and what they're asking is you want to find the length of this tree, a very practical application. So how do we start? You want to look at this bigger triangle, you want to ignore this and just look at this particular angle here with 22.2 degrees. So let's try to draw that real quick. Now in this triangle, you've got 22.2 degrees over here, 22.2 degrees over here, and then you're given this length is 50, so this is also 50 like we discussed before. So this is 50, and then you first want to find out this length. So remember, in this problem, you just want to remember one thing, that tan is equal to opposite over adjacent, SOHCAHTOA, right? So it's the TOA part of SOHCAHTOA. So tan is equal to opposite over adjacent. So what is tan? Tan is 22.2 degrees, and that is equal to opposite 50 over X. So now you're going to find out what is the X value. So you cross multiply this. So X goes over here, and then you can write down X is equal to 50 over tan of 22.2 degrees. So when you put this in the calculator, the answer you're going to get is 122.5213. So let's write this down, and then we're going to use this for the next step, which in other words, this length over here, or this length, is going to be equal to 122.5213, and then we'll use this to find this length now. All right, so we've used this big triangle over here to calculate this particular length. Now this length is shared with the smaller triangle as well here. So now let's look at only the smaller triangle. So of course the smaller triangle angle over here is 13.3 degrees, and this length is 122.5213. Now the goal is to find this length, so let's call it y, and then again let's use the same tan formula. Remember, tan is equal to opposite over adjacent. So in this case 13 degrees you've got, so tan of 13.3 degrees is equal to y over 122.5213. Now if you want to find y, just cross multiply it or multiply it on this side. So you get y is equal to 122.5213 is equal to times tan 13.3 degrees is equal to y, and then when you evaluate this value of y, you're going to get the answer of 28.9628. You can check it in your calculator. Now if this one is 50 and this is 28.9628, then of course it's easy to evaluate this length. It's just going to be 50 minus this value. So 50 minus this value, right? 50 minus this value, that gives you roughly 21.03. And so when you round it, you're going to get the value of 21. So 21 meters is your answer for this problem. This length is 21 meters. So remember, to solve this problem, we looked at this triangle here first, and we found out this particular length was 122 point blah blah blah, and then you use this 122 to find out this smaller length, which was 28. Then you subtracted 28 from 50 to find this length, which was roughly 21. Now your goal is to find out the same length, but instead of 50 you want to use a different value. Let's say let's take a value of 25 meters. So see if you can find the answer if this is 25 meters and find the length of this tree. All right, post your answers and talk to you soon. This is a very easy trig problem. Remember, you're given CDE, which is this triangle here, is the image of CAB, which means it's just kind of like a photograph. It's made bigger or smaller. So in other words, these two triangles, they are similar to each other. So when things are similar, right, the signs are also similar, or the angles are also similar. So this A, right, is exactly equal to D. So in reality, what they're asking is, let me just redraw this for us here. You've got DEC here. I'm just drawing this smaller triangle here, DEC. And if they're asking you sine of A, really what they're asking you is sine of D. So let's try to rewrite this. Remember the SOHCAHTOA formula. You got SOHCAHTOA blah 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 over here, right? SOHCAHTOA. So sine is equal to opposite over hypotenuse. So if you've got sine of A, which is sine of D really, so what is the sine of D? The sine of D is the opposite, which is this side. Remember, the D is this part over hypotenuse. So let me use a different color here. It's this length over this length. So let's just write this down over here. This length is EC, because you see it's EC over here, E to C. So it's EC over the hypotenuse, which is CD over here. So that's CD. And so therefore, sine of A is CE over DC right over here. So therefore, this is your answer. Now it's your turn. Try to find out what is the cosine of A equal to. Remember, cosine of A here in this triangle is going to be cosine of D again. And so you just go to D over here and then use the SOHCAHTOA formula here. The cosine is equal to adjacent over hypotenuse. So what's the adjacent of D? What's the hypotenuse? And then type your answer in the comments. So this is a very easy and standard trig problem. You're given a right triangle TMR. So let's already draw it, and you're given these ratios and you just want to compare them. So let's easy way to draw them is just to have a right triangle, and anytime you draw this, one side could be 3, the other side could be 4, and this could be 5. This is a very important idea. And then you have the right triangle at right angle at M. So I'll just write M here. This could be T. So it's TM R over here. Now let's try to find the actual ratios. So the first thing is, in these equivalent points, anytime you see this right triangle, this M, you just automatically cross it off, because that's an easy incorrect answer. Now you only want to compare these two. So let's start with this value here, sine of T. So sine of T is how much? So remember, you want to remember this formula, SOHCAHTOA, right? So SOHCAHTOA over here. So sine of T is equal to opposite over hypotenuse over here. So what is the opposite of this T angle? So how do you find the opposite? The opposite is always the side which never touches it. This is the adjacent side. This is the hypotenuse, and remember, the opposite is the one that never touches it. It's like away from it. So therefore this is equal to 4, the opposite, and the hypotenuse is always obviously the longer one, which is 5. So sine of T is 4 over 5. And then let's try to find out, looking at this one over here, cosine of R. What is cosine of R? Here's R. So you're just going to write down over here, this R value of the cosine of R is going to be equal to adjacent over hypotenuse with respect to R. What is the adjacent of R? It's 4. So you write down 4, and then the hypotenuse is always 5. In any case, it's 4 over 5. So you see, sine of T is equal to cosine of R, and so therefore this is the correct answer. Now remember, this is an important property here, which is called the co-function property. It's tested on many tests here. It means that the sine of this angle is always going to be equal to the cosine of this angle, and then the sine of this angle is going to be always equal to cosine of this angle. Now it's your turn. See if you can find out the sine of r is equal to cosine of which angle. That's the first question for you. Sine of r. So the way you do it is you find r, right? Sine of r is always going to be here opposite over hypotenuse. So you'd write down 3 over 5. Now blah 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 blah, which cosine of which angle is going to be equal to 3 over 5 as well. That's the first question. The second question, which is going to strengthen your understanding, is what is the cosine of t? Cosine of t is equal to what of r? Is it going to be sine of r? Is it going to be cosine? Is it going to be tangent? Very easy. Find the cosine of t here. Cosine of t is 3 over 5, right? And then you want to find out sine of r or cosine of r or tan of r is equal to also 3 over 5. So these are your two questions. Which function of r is equal to cosine of t? That's your second question. So comment your answers and let's move on. Okay, this is a very easy problem. You're probably not able to see this, so I'm just going to redraw this over here. You're given a tree over here and you're given this basic triangle over here. What they've given is this length over here is 140 degrees. Sorry, 140 feet. Then you're given this angle over here is 100 degrees, and then you're given this is 90 degrees, and they're asking you what is this length. So if this is 100 degrees, that's the most important thing. This part over here from here to here is 180. So if this is 100, then how much is this? This is 80 degrees. Now you just want to use this basic idea of SOHCAHTOA. So you've got SOHCAHTOA here, and you're given this length is asked and this length is the adjacent. So you've got adjacent and you've got hypotenuse, so you're going to use cosine. So you say cosine of 80 degrees. Cosine of 80 degrees is equal to adjacent over hypotenuse. So what is adjacent and what is hypotenuse? You've got x over 140. So now how do you find x? You multiply by 140. So you get x is equal to 140 times cosine of 80 degrees. So therefore, what is this value? You will calculate this value and you will get the value of 24.31. And then of course the unit is in feet. But now they're asking you the nearest foot. So how do you do this? You round it down, not up. So the answer is 24. And so therefore, this is your answer. Now it's your turn to solve this problem. Now remember, instead of this being 100, let's change this and let's make this 120 degrees here. So this is 120. Remember, this is going to be 180 minus 120, which gives you 60 degrees. Then you want to use the cosine of 60 formula, and then you write x over blah blah blah, and then you want to find out x. So I'm waiting for you to solve this on your calculator and find the answer and comment it. Let's move on to the next problem. This is a very wordy problem, but actually it's super easy to solve. We are not able to probably see exactly the number, so let me rewrite this problem here. You're basically, the triangle is drawn. You're given this length is 86.03 degrees, and then you're given this height is 183.27, and then you're asked this length over here. So how do we solve this problem? Simple. You just use SOHCAHTOA to find it. So you will use what's the exact ratio you're going to use. You're given this angle, you're given this side, which is the opposite because it never touches it. The ones that touch are the hypotenuse and the adjacent, this is the opposite. So of course you're going to use this value here. You're going to write down sine of 86.03 is equal to opposite over hypotenuse, right? What's the opposite here? It's 183.27 over x, and then you just simply multiply, cross multiply them. So x times sine 86.03 is equal to 183.27. Now how do you find x? You simply divide by sine 86.03, and then you can plug in your calculator and then you'll find the value of 183.71. I think it'll be very helpful if you can actually plug it and see if this is indeed the answer that you get. All right, now it's your turn to actually solve another problem. What is this length over here? So call this y, and then again, remember you have this ratio, so you can write down this part is the adjacent and this part is the opposite. So you got adjacent and you've got opposite. So how can you write this ratio? You can write opposite over adjacent and you use tan. So you can find out tan of 86 point blah 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 is equal to the opposite, which is 183 over y, and then try to find out the value of y and comment your answers. Let's see if you can solve it. This is a very important problem to understand. You're asked to find out what is this angle theta, and these lengths are given over here. So this length over here is 1.17, and this length over here, this length is 1.17, this length over here is 0.4 0.41, and then this length is also given to you. It's 3.74. With these three lengths, you want to find out this angle. So how do you find this angle? The first thing is you want to find out this bigger angle here. Then you find out this smaller angle here, and you subtract them to get your answer. So let's try to find out this bigger angle. So I'm just gonna real quick, I'm just gonna draw this over here so it's easier to see this. Now you've got a right triangle, you've got two right triangles. I'm just taking this bigger right triangle, drawing it over here. These two lengths added is going to give you this length, and when you add them, you're going to see 0.41 plus 1.17 is 1.58 over here, and then just copy this down over here, 3.74. So what is this angle? Is theta. Now remember, whenever you're given two sides over here and you're asked to find the angle, you always want to use this shift theta, shift tan kind of function, right? So first let's try to find out what is this formula. Tan of theta is equal to how much? Remember, in the SOHCAHTOA method, you always have tan is equal to opposite over adjacent. So you write down opposite over adjacent. What's the opposite value and what's the adjacent value? Let's try to evaluate that real quick. You've got tan of this value here, tan of this theta is equal to this part here is the opposite because it never touches the angle. That's how you evaluate the opposite. That's how you determine the opposite value. So it's 1.58 divided by 3.74. Now if you want to find theta, what do? You're gonna write down this way in your calculator. You're just gonna do this. You press the shift button or that second button, and then you will press the tan button and then just put in this ratio 1.58 over 3.74. So when you put this value in, you're going to get the value of tan as 22.90. So remember, this is how you find the value of tan. You put the shift tan and then this ratio directly in, and then you press the enter button. You're going to get this value, which is 22.90. So therefore this bigger angle is 22.90. Now let's try to determine the smaller angle the same way. All right, now we're looking at the smaller angle because once we have the smaller angle, that's almost all that we need. So how do you find this angle? So let's call it like x or something, right? So you've got 0.41 here and this is 3.74. Again, you want to use the SOHCAHTOA formula. You've got TOA here, so tan of x, right? Tan of x is equal to 0.41 divided by 3.74. That's basically because this is the opposite is the OR, right? Is the opposite and this is the adjacent. So this value, you don't even have to evaluate it. To find the x, what do? You press the shift button again, or the top left button on your calculator, the button that's probably over here. Then you type tan and then you just put in 0.41 and 3.74, and then you press the enter button. Once you do that, the answer that you're going to get is 6.26 degrees. Okay, so we've got two values now. We've got this bigger value earlier, which was about 23 degrees or so, and then the smaller one, which was 6.26. So one more time, we've got this 6.26 degree here, and then you've got this bigger angle. This bigger angle is 22.90. So now what are they asking us? They're asking us this angle. What is this angle over here? This particular angle is going to be equal to just the difference between these two. So this angle is equal to 22.9 minus 6.26. So let's just write this down, 22.9 minus 6.26. That gives you the answer of 16.64 degrees. But they're asking you the nearest tenth. Remember, sometimes you can lose points of this. So the actual answer is just 16.6 degrees, and that's your answer. Now you try to solve the same problem. Remember, instead of this 3.74, you want to just use 4, a much easier number, and try to find the answer. So remember, the main thing is you want to first find out what is this angle, then you want to find out this angle. You subtract both of them and then you will find it. Remember, don't forget to use the shift tan concept and try to find this answer. So try to find this answer. What is this theta? What is the theta equal to if this length is 4? And of course you've got these lengths, and comment your answers.